All right, everybody, welcome back to the deep dive. Today we are we're diving deep into some seriously cool science that came out of the OSIRIS-REx mission. You know, the one that brought us the first U.S. asteroid sample? Pretty amazing in itself, right?
Absolutely incredible.
But here's the thing. While everyone was celebrating that achievement, something else incredible was happening, something that's really going to change how we think about space travel forever. We're talking about the capsule's re-entry and what it taught us about how objects behave when they come screaming through our atmosphere at thousands of miles per hour.
Yeah, you know, it's funny. What's really mind-blowing to me is the sheer scale of the effort. To
Right.
capture this data, imagine a team of over 80 scientists spread out along hundreds of miles of what's known as the loneliest road in America, all waiting to observe this tiny capsule as it enters the atmosphere.
Wait, 80 scientists on the loneliest road? That sounds more like the setup for a sci-fi movie than a scientific observation.
Huh. It might sound a little unusual, but think about it. We're talking about capturing data from a meteor-sized object, traveling at hypersonic speeds. It's not exactly something you can just point a telescope at and observe leisurely. This required hundreds of sensors strategically placed to capture every nuance of the capsule's fiery descent.
So it's not just about what OSIRIS-REx brought back from the asteroid. It's about what we learned from watching it come home. I'm already hooked. Tell me more about this data.
Yeah, so one of the most exciting aspects of this whole observation campaign was the use of a cutting-edge technology called distributed acoustic sensing, or DAS. And get this, it was the first time DAS was ever used to record an event like this.
Hold on, DAS. That sounds pretty high-tech. Break it down for me. How does this DAS thing actually work?
Okay, so imagine a spider web stretched across the desert. The slightest vibration, even a fly landing on a strand, can be felt across the entire web. That's how sensitive DAS is. It uses a fiber optic cable to sense minute changes in the environment. So when the OSIRIS-REx capsule entered the atmosphere, it created a sonic boom, right? Well, that sonic boom didn't just travel through the air. It also created vibrations in the ground. And DAS, with its incredible sensitivity, picked up those vibrations.
So you're telling me we can use the Earth itself to listen to a spacecraft entering the atmosphere? That's incredible. Did it actually work, though? Did they get the data they were hoping for?
That's the truly amazing part. This was a first-time attempt, and it was a resounding success. They captured clear data of the sonic boom rippling through the ground. It's groundbreaking stuff. It opens up a whole new world of possibilities for studying other hypersonic events.
Okay, so we have all this data from this incredible observation campaign, but I have to ask, why does all this matter? What's the bigger picture here? Why should we care about how a capsule enters the atmosphere?
So understanding how things enter our atmosphere, especially at those incredible speeds, is crucial for a whole bunch of reasons. Think about it. We send probes to other planets, astronauts to the International Space Station, and even satellites that help us navigate and communicate here on Earth. All of these things eventually have to come back down.
Right, and they need to come back down safely. But how does this DAS data actually help with that?
It helps us refine our models, those mathematical simulations we use to predict how objects will behave during atmospheric entry. For a long time, these models were based on limited real-world data, especially for something as controlled as the OSIRIS-REx capsule re-entry.
So this real-world data is like adding a whole new layer of detail to those models, making them more accurate and reliable.
Exactly. It's like trying to bake a cake with only half the ingredients. You might get something that resembles a cake, but it's not going to be the perfect, delicious creation you are hoping for. This data from OSIRIS-REx is giving us those missing ingredients, allowing us to create models that are much more precise and predictive.
Okay, I'm starting to see why this is such a big deal. But let's talk practical applications. You mentioned spacecraft design earlier. How will this data actually change how we build spacecraft in the future?
Well, one of the most important aspects of spacecraft design is the heat shield. That's the part that protects the spacecraft from the intense heat and pressure of atmospheric entry. With this new data, we've discovered that some of our previous heat shield designs were actually over-engineered by as much as 15%.
Great. So you're telling me that we can build lighter, more efficient spacecraft because of what we learned from watching OSIRIS-REx come home?
That's exactly right. Lighter spacecraft mean we can launch bigger payloads, travel farther, and do even more amazing science in space, all thanks to the data we gathered during this re-entry.
Wow, that's a pretty incredible ripple effect. And you also mentioned something about tracking space debris. How does this data play into that?
Yeah, space debris is a huge problem, and it's only getting worse. Thousands of defunct satellites spent rocket stages and other bits and pieces are whizzing around our planet at incredible speeds. And even a small piece of debris can cause catastrophic damage if it collides with a functioning satellite or spacecraft.
Right, it's like a cosmic minefield up there.
Exactly. And this data is helping us understand how those pieces of debris behave during atmospheric entry. It helps us predict their paths, estimate where they might land, and even develop strategies to mitigate the risk of collisions.
So it's about protecting our assets in space and making sure that we can continue exploring safely. This is starting to feel a bit like a space-age CSI investigation.
Uh-huh. I like that analogy. We're piecing together clues, analyzing patterns, and using this data to create a clearer picture of what happens during these high-speed events. And that picture is going to help us protect ourselves, our spacecraft, and the future of space exploration.
This has been absolutely fascinating. Okay, so we've talked about the data from the re-entry and its impact on our understanding of atmospheric entry. But let's shift gears for a moment and circle back to OSIRIS-REx itself. The spacecraft has a new mission, right? Tell me about OSIRIS-APEX and its rendezvous with asteroid Apophis.
Ah, yes, OSIRIS-APEX. Now, there's a story with a bit of drama attached.
Oh, all ears.
Well, you see, Apophis has a bit of a reputation. It's been dubbed a potentially hazardous asteroid because of its size and its close approaches to Earth. Of course, its orbit is well understood and there's no immediate threat, but it's still an object that has got the attention of scientists and the public alike.
Potentially hazardous asteroid. Okay, now you've really got my attention. What are we hoping to learn from this close encounter?
By studying Apophis up close, OSIRIS-APEX will give us a wealth of information about its composition structure and even its history. This knowledge is vital for developing effective planetary defense strategies. Think of it as a dress rehearsal, preparing us for a scenario we hope will never happen.
So we're learning how to protect ourselves from potential asteroid threats, all thanks to a spacecraft that's already achieved so much. This mission just keeps getting more and more interesting.
It truly is a remarkable testament to human ingenuity and our drive to explore the unknown. And the story is far from over.
Okay, we're back. Ready to wrap up our deep dive into the OSIRIS-REx mission. It's been quite a journey, huh? We've gone from collecting an asteroid sample to uncovering groundbreaking data about atmospheric entry. And we even touched on the spacecraft's future mission to a potentially hazardous asteroid.
Yeah, and we've only just scratched the surface. It's amazing how much we've learned from a mission that wasn't even designed with all of this in mind.
That's what blows my mind. It's like we set out to find a needle in a haystack and stumbled upon a whole treasure chest instead.
Uh-huh, a perfect analogy. And that treasure chest is full of knowledge that will shape the future of space exploration for years to come. But it also goes beyond that. This mission has implications for all of us, right here on Earth.
Okay, I'm intrigued. Explain that one to me. How does all this space stuff connect back to our everyday lives?
Well, think about it. Space technology is woven into the fabric of our modern world. GPS, navigation, weather forecasting, communication satellites, these are all things we rely on daily. And they wouldn't be possible without a deep understanding of space.
Ah, I see what you mean. It's easy to forget that space isn't just some abstract concept out there. It's directly connected to our lives in countless ways.
Exactly. And the more we learn about space, the better equipped we are to solve problems here on Earth, from developing new technologies, to monitoring climate change, to even protecting ourselves from potential asteroid impacts. The knowledge we gain from space exploration has a ripple effect that extends far beyond the cosmos.
So it's not just about exploring the universe for the sake of exploration. It's about using that knowledge to improve life on our own planet.
Precisely. The beautiful cycle of discovery and innovation. And the OSIRIS-REx mission is a prime example of that. We set out to collect a sample from an asteroid. And in the process, we unlocked a wealth of knowledge about atmospheric entry, spacecraft design, and even planetary defense. Who knows what other discoveries are waiting to be made?
That's a great point. And speaking of discoveries, I want to leave our listeners with a final thought to ponder. We've talked about how OSIRIS-REx's re-entry gave us a unique opportunity to study atmospheric entry using this incredible JAS technology. But what other space events could we study in similar ways? What other secrets might the Earth be whispering to us if we just listen closely enough?
That's a fantastic question. The possibilities are truly endless. From meteor showers to satellite re-entries, to even the atmospheric effects of distant supernovae. There's a whole universe of events happening out there that we could potentially study using these advanced techniques.
So keep your ears to the ground and your eyes on the sky as deep divers. There's a whole world of discovery out there waiting to be explored. And who knows, maybe one of you listening right now will make the next groundbreaking discovery.
Never underestimate the power of curiosity and a thirst for knowledge. That's what drives us forward, both in space exploration and in every aspect of our lives.
Well said. Thank you for joining us on this incredible journey. We hope you've enjoyed this deep dive into the OSIRIS-REx mission. Be sure to subscribe to the deep dive for more explorations into the fascinating world of science and discovery. Until next time, keep exploring.